Okay, today we are doing inverse of functions. So as you may know by now, mathematicians like to look at graphs and then they like to check it for all these random facts. So we're going to go over right now a review of the major random facts that mathematicians look for. All right, so first things first. What do we already know that mathematicians are looking for? A relation. We can pair anything up. Apples with the number 3. Chair with microphone. We can pair anything together. That's the first word. Now, after we do that pairing, mathematicians look closer at the relations and they say, if the x values don't repeat, then we're going to call this relation a function. All right, next thing we knew, we look at if it's 1 to 1. That's when the y values don't repeat. Then we look at the function, the graph even closer, and we see if it's a 1 to 1 function. Remember, 1 to 1, the y's don't repeat. Function, the x's don't repeat. So this is when both the x and y values don't repeat. Then we learned about onto. This is when all the range values have something mapped onto them. So everybody is onto something. And the last word we have for this chapter is inverse. To take the inverse of anything, we simply switch the places of x and y. And you've actually done that in geometry. You'll see what an inverse is, and you've been doing it all along going, oh, that's an inverse? So an inverse, we simply switch the places of x and y, and this is what you did in geometry. It needs to reflect over the line y equals x. Remember when you did that in geometry, you had to memorize all those different rotations, reflections, translations. Well, here it is. This was reflecting over the line y equals x. That's called an inverse. So if you remember how to do an inverse, if you remember those, inverse means we switch the x and the y. So right here, if we were to take the inverse of each one of these sets, this new inverse would be 5, 1. This would be 7, 2. And this would be -2, 3. And if you see up here, we have new notation. We know that this is fancy for y, and it means function. If we want to do the inverse of a function, we raise it to the -1 power. Now we raise the notation to the -1 power. So let's say this was called function g. Then this would have been called function g prime. That's how we say it. G prime. Okay, let's do this one over here. Let's pull this down over here. And what do you want to call this? Let's call this set R. Let's call this function R. So if I asked you to do R prime, your little hamster in your head would go, oh, R prime. Prime means inverse. Okay, how do I take the inverse of this? Oh, I just switch x and y. So my new function would be ft, no, yes, and white, black. Very simple. All right, so with upper level math, we're always dealing with graphs. We want to study graphs. Mathematicians make everything into graphs. I'm going to say that now and probably every day, and you're going to hear that in pre-calculus and calculus. take something and make it into a graph so we can study it. So you know the baby graphs right now, and here's a baby graph right here. This, hopefully when you look at it in your mind, you say, oh, this is a linear graph. It's linear because this has a degree of 1. Degree of 2 would be a quadratic, like we talked about the other day. Degree of 3 would be a cubic. Great, but that's not what we're doing today. Today we want to write the inverse. So, how do we go about it? Inverse means to simply switch x and y values. So, when I come over here and look at this graph, do I have a y value in there? Yes, yes I do. Remember, the f of x is really the y value. So if you want to cheat for a little bit and turn that into a y to make yourself happy, go right ahead. So now let's just switch x and y. Look at that, they switched spots. The x went to where the y is, and the y went to where the x is. I just switched their spots. Now you know all equations have to be solved for y. So now I'm going to have to take this equation and solve it for y. That means move the 6 over to the other side. And we have y equals x plus 6. There, we did the inverse. So if we are professional and we want to use function notation, we remember that inverse means we have to prime. So there we go. That's the inverse. This function here, and then that's its inverse. Okay, what you have here is a visual representation of what we just did. This red graph represents the original, and then the blue graph represents the inverse. And then this yellow line right here represents y equals x. Or if we were using function notation, f of x equals x. And remember, I told you the inverse simply means to reflect over the line y equals x. So this point right here, which is the point 6, 0, gets reflected over onto this point right here, which is 0, 6. Get it? The x and y values just switched. And when you reflect over something, that means that the lines have to be perpendicular to the line they're reflecting over. So this point and this point, obviously, as you see when I draw a straight line, they are perpendicular to that line of reflection. And I can do that with any other point. Let's pick, hey, this looks like a nice point right here. This is the point 1, negative 5. Okay, if I reflect that, if I take the inverse of that, that becomes right there, negative 5, 1. Okay, let's just run through one more really quickly. Take the inverse of this function. Okay, inverse tells me to switch in the x and y values. All right, so I'll switch the x and y values, put my y value in. I will now switch the x and y. So once I switch the x and y, I get x equals 6y minus 2. See, just did that. That x went there, that y went there. Okay, next step, solve for y. All functions have to be solved for y. So I'll move the 2 over and end up dividing by 6. There's my new inverse. Write it professionally in inverse notation, and that's what I get. And a quick review also, if I wanted to take the inverse of this function, right, this is a parabola, and I know I should have arrows on the end, but do the best I can with my little limited artistic skills. Okay, I don't have anything equation-wise, but I do have points that I can take. So if I look at that point right there, that looks to be the point 3, 5. right? And if I look at this point right here, this looks to be the point -3, 5. And then I got some other points right here. All right, so let's change color. Let's use green. 3, 5, when I reflect that point, becomes 5, 3. When I reflect this point, inverse this point, it becomes 5, -3. And 1, 1 becomes 1, 1. And this is the point -1 up 1 becomes 1, -1. So if I took the inverse of this red parabola with my best artistic skills, that would be the inverse of that beautiful parabola. And just to prove it to you, I'm going to quickly draw the line y equals x. So that's where -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. There we go. There's my line y equals x. And I have a beautiful reflection going on over the line y equals x. That's it. See you tomorrow.